There are many ways to perform predictive maintenance, and pretty much it depends on the situation and the type of data we are dealing with. In this lecture, we're going to download the data that we will use in order to predict the remaining useful life of an engine, an aircraft engine. The concept here is going to be the same that you can apply for any other machine. However, as I said, depending on the data, the models and the methods we use to predict the remaining useful life will change. For example, in this situation, we will take the property of the engine, the instant property, and predict the remaining useful life. In some other cases, you will need to use time series data to predict as an input to predict the remaining useful life. In this, we will use the property and not time series data. So first of all, we need to download this data. And to do so, we can go to this link that I'm going to put in the resource. And also I will put the downloaded data into the resource. So this link is actually for NASA made data. And here you can see that they describe the type of data we have, which is multiple multivariate time series data. Of course, it says time series, but we're not going to use the time series as an input for our model, although the data is time series. Each dataset is further divided into training and test subset, and so on. We will download this data. You can read all of here. The most important thing is the columns. It has the first one is a unit number, and then time in cycles, which is very common or not very common. It's pretty much the aircraft engine has two ways to predict its life. The first one is cycle. The second one is actual time, like operation, like just the operational time we use it for. So cycle usually refer to an airplane that go up and go down. So one cycle is the engine went to the air and the airplane landed, of course. This is one cycle. Now they have 3 operational settings, and after that they have some sensor measurements. So this is basically the data, and here you can see the sensor measurements happen. These are inside the data. There are other categories, and here you can see the fault module, for example, HPC degradation, which is high pressure compressor degradation. And you can go here, even there's another types of failures that happen. However, let's just download the data and see how it goes. So the first thing is, first you download the data, and of course you go to the downloaded material, and we just extract this data. I'll just get it here, and we just extract it. And now we have the data folder. Here you have README. The README is more or less similar to the website. However, the nice thing that comes with this data is this paper, and this paper, it's IEEE paper, and it has a description how these data got generated. So it seems that these data are actually simulation generated data. And here it explains how the simulated model works. You can see the general engine like structure, or like basically the system itself. And you can see here it is a 2-spool engine, we call it, which is it has the one core rotating. So this is a compressor and turbine connected with each other and rotating with the same speed. And the other one, which is the low pressure side of the engine, and this blue one is the other spool. Of course, this is the combustor. This one is connected with the fan, and this one we can call it LPC. LPC is low pressure compressor, HPC high pressure compressor, and HPT, which drives the high pressure compressor, is high pressure turbine, and of course LPT, which is low pressure turbine, and this is the core. All of this is the core, and this is the outlet, the nozzle, the first nozzle or the core nozzle, and of course there is the fan, and there is the fan nozzle here. It gets the jet out. So this is basically the system configuration we are dealing with. Now here, nice thing is they also describe the data. So sorry, this one. So here you can see the total temperature fan inlet, total temperature LPC outlet. All these measurements is actually exist in the data itself. So we will use these ones to construct our engine data. Yeah, so this is the description. Now we will use the FD001, which is the simplest case. So here is basically, this is the remaining useful life that we will train. Like, this is the predictive of the test data. The other one is the train, and of course we will go through the data more detail. We can see here is the actual data. This is, every one is column. So one is engine unit 1. You can see not so much from engine unit 1. It's only 100 engine here, so you can just scroll down, you can find it reaches 100. And so this is the engine unit. This is we go again to the readme file. We can see here the unit number, so this one, and then we can see the time in cycle. So this is the cycle. Here operation setting 1, 2, 3, operation setting 1, 2, and 3, and then it will measure the sensor's measurement, which is we can find from the paper itself. I think this one, which is start from this one, the outlet, the total temperature at fan inlet, and then total temperature of LPC, total temperature of HPC, and total temperature of LPT outlet. So these are 3 temperature values, this one and this one and this one, and it makes sense actually. As you can see, we go through from the cold side of the engine to the hot side, which is after the combustion chamber. We have the pressure of inlet and total pressure. So basically all the data we need exist in this file.